Greetings, welcome to video 2. In this video, we're gonna do and work with all these questions and we're gonna solve all of these problems. You might be asked some of these problems, you might be asked all of these problems, but the methods I'm about to use will give you the answer to all those problems in 3 simple steps. So let's take out the first sample that we have in our table. And we're gonna go into our template. So let's copy the IP address and put it right here. And I'm going to give it a little font increase so we can see better this number. That should do it. Okay, so we're gonna use our template right here, which is the binary table and the answer template. That is gonna guide us step by step how to solve this specific problem. The templates can be used with any problem, so there is no difference. Okay, so let's start by identifying the first problem. What is the subnet mask? We need a subnet mask in order for the IP to be routed properly to the right network. The subnet mask, since we are using only the last octet, our subnet mask is going to be 255, 255, 255, the first 3 octets. And how do we find the subnet mask for this IP address? We're going to use the cidr notation that is given to us. 28 is the cidr notation. And we're going to come to our table and we're going to pick the /28 cidr notation that we have. And we're going to highlight this column. And this is the column that we're going to be working only. Okay, so we are on the 28, our subnet mask. I should specify that here. Subnet mask is going to be 240. So that's the value we're going to put right here. 240 is going to be our subnet mask for this routable IP, right? Number 2, we're going to find the number of subnets. And we have a formula here that says the number of subnets is found by multiplying or elevating to the power of 2 the number of bits. We are on the bit 28. That means we are borrowing 4 bits. The powers of 2 row is giving us that power, those bits that we taken from the 4th octet. This number translates into 16. This 16 is the subnet size, but it's also giving us the number of subnets. In other words, we have a total of 16 subnets. Okay. Now, we need to find not only the next network, but we need to find the previous network and the current network of this IP. In order for us to figure out that, we need to pay attention to this last IP number, which is going to give us the range of the previous network, the current network, and the after network. With that, we can deduct all the networks and all the ranges in this IP given. So how do we do that? We pass the given IP, use the number after. So in other words, this is the given IP, 55. How do we get to that again? We start at 0 and increase by the group size. Our group size is in our IP, in our binary table, our group size is 16. So we need to start at 0, move 0, 16, 32, 48, 64, until we pass this number. And I'm going to do that in writing here. So following these instructions, start at 0 and increase by group size, which is 16, we're going to do 16 plus 16, 32, plus 16, 48, plus 16, 64. We already passed the number. So right here, in between, this number is laying down. In other words, our network that this IP is located is the network 48. This is identifying our current network. The 64 is identifying the next network. Okay? And these numbers are identifying the previous networks, network 0, network 16, network 32. But we are only interested in this network. In this case, we can answer this question by typing what is the value of the next network. And the value for next network is 10.1.1.64. From here, we have calculated the most difficult part. At this point, that's all we need to do. All the remaining information that could be asked or is asking, it can be deducted from this information we got so far. So what is the network ID that we have this IP? Again, we got it right here. Our network ID is 48. So we're going to type in 10.1.1.48. That's our network ID. Let's go for the next one. What is the broadcast IP? In order for us to get the broadcast IP, we need to use the last IP in each network. So we don't want to type in all the IPs on each of these networks, although we could, but if we have long ranges, we don't want to waste time on that. So the easy way to look at the broadcast IP is look at the number before the next network. Our net network is 64. The number before is 63. That will be our broadcast IP. 10.1.1.63. Now, how do we get the first host in this range? Well, the first host is going to be the IP address plus 1 after the network ID. Our network ID is 48 plus 1 will give us 49. That is our first host. So that's 10.1.1.49, 48 plus 1. Now, the next item is the last host IP. That will be the IP address minus 1 of the broadcast IP. We already calculated the broadcast IP as 63, so we subtract 1 and as 62. 10.1.1.62. That will be our last host. The next one is the total of IP addresses that we have. The total available IP addresses in the network is the same as the group size. What is our group size? 16. So we have 16 available IPs. Now, the last one. What is the total usable IP addresses? Remember, usable IP addresses is not the same as available IP addresses. Usable IP addresses is the one that we're going to use for our host. And we have a formula here that states 2 to the number of bits minus 2 will give us the number of hosts. What is the number of bits? Again, is given to you right here, 4. 2 to the 4 is 16. 16 minus 2 is 14. That will be the number of available hosts. 16 minus 2 is equal to 14 available host IPs. And that's it. We solve all the problems just by getting to step 3. Okay? The remaining information can be just obtained out of this counting that we do along with our binary table. So use this table for future exercises. I'm going to create another video with another sample. And Watch for the second video.